Okay, so hi there, folks. We're now on our next video about the algebraic fractions, and in this one, this is the last part of our algebraic fractions lessons, and we're going to talk about complex fractions this time. Okay, complex fractions. Okay, so a complex fraction, okay, is one with which has one or more fractions in the numerator and or in the denominator. So we shall say that in simple terms that a complex fraction is there is a fraction within a fraction. Okay, so there's a fraction within a fraction. So there is a fraction, the numerator has more fractions in it, and the denominator has more fractions in it. So and or. Okay, it's not going to be all the time that both of them. Maybe in the numerator it has more fractions than in the denominator. The thing is, it's kind of complex to see. Okay, in which you will see in a short while. So how do we simplify complex fractions? How do we do the simplifications here? So first, first up, we will need to reduce, okay, the numerator and the denominator into simple fractions, wherein we're going to look at it in a way wherein there's a single linearly way to see the numerator and a linearly way to see the denominator. As I what I mean when I say linear is that there is one straight expression. Okay, there's no more fractions, shall we say. There's no more fractions in the numerator side and also no more fractions in the denominator side, wherein we're going to see a simple fraction, shall we say, where it's composed of a single expression numerator and a single expression denominator, in which you will see that in a while, what I mean. Okay, and then after that, we will divide the two resulting fractions. Okay, we will divide the two resulting fractions. And we will see that in this example over here. Yes, our first example, and you will see here. So our first example, we have here that for number one, we have x plus 2 over x all over 1 minus 3 over x. So we can see this is a complex fraction because in the numerator, we have an expression which has a fraction, which makes it complex. Also in the denominator, we have part of the expression has a fraction, which makes it complex. Okay, so this is one example of a complex fraction. As you can see, by the way it looks, it's kind of complex. Okay, so let's do this step by step and let's explain it in such a way that everyone can understand. Okay, so again, the first step is to reduce the numerator and the denominator into simple fractions. So we're going to talk about here, let's make this by piece or by parts. So let's talk about the numerator first. Let's call that numerator. So our numerator is clearly x, okay, x plus 2 over x. So we want to make this a simple fraction, okay? We want to make this a simple fraction and then we're going to divide it from there. So how do we make this a simple fraction? So make them under one or over one denominator in that essence. So we need to find the LCD. So imagine the x here to have x over 1. So what's the LCD of x and 1? So it's only going to be x. It's only going to be x. So this is going to give us, this will produce x divided by 1 is still x times x is going to be x times x. So it's going to be x um, times x. This is the numerator. This is the one that we multiplied on the numerator so that we can have an x in this part, plus we have 2 over x. Okay, so now since they have the same denominator, we can combine them and put them over one denominator. We have over x. We have x times x here, which is clearly x squared, and then plus 2, plus 2. So this is going to be our numerator. Okay, this is our numerator. And then we're going to fix our denominator in the next part. So for our denominator, let's call it dem. Okay, shall we have it? Or den rather, denominator. Okay, so our denominator is clearly we have 1 minus 3 over x. So 1 minus 3 over x. 3 over x. Um, so what we're going to do is to make it similarly with the one that we did before in the expression above. So let's make it clean. So what we have here is to make them all over x. So this one here will have, it's going to be x over x. Well, which is equal to 1, right? It's x over x, or x times 1 if you want, if you really want to put the original numerator, it's going to be like this. So we have 1. Okay, so that's it. And then minus 3 over x. Okay, 3 over x. So we have it there. Okay, and then since they are now similar fractions, let's make it simple. It's going to be all over. They're all gonna be over x. And then c is gonna become x times 1 is x. So x minus 3. X minus 3. Okay. Oops. Sorry. Okay, so that's it. So this is our, again, this is our numerator, this is our denominator, and then let's put that and present that as a fraction right now, since we answer them separately, right? So let's put them under with a fraction bar right now. More space, I believe. Okay, so let's continue. This is going to become so therefore this becomes um x squared plus 2 all over x, um, all over x minus 3 over x. Now, if this is the case, we can now proceed to division. Okay, we can now proceed to division if this is the case here. So if we're going to divide, actually, it's like, since they have the similar denominator, we can cancel that up, actually. Why do we do that? This is because of this. So we know that dividing is also like, or rather, fractions. The fraction bar can be written as dividing. So we can rewrite this as, so let me write this um, clearly. Delete this one. Okay, to save some space. So we can rewrite this as um, x squared plus 2 all over x divided by, so divided by x minus 3 all over x. And then, now, remember our lesson in division of fractions, or division of algebraic fractions, shall we have it? What are the steps in dividing fractions? First, we need to get the reciprocal of the divisor. So I'm referring to this term here. That's our divisor. And then we get its reciprocal, and then we proceed to multiplication. So if we do that, so copy the thing here, expression x squared plus 2 over x. Okay, and then proceed to multiplication and then get the reciprocal of this. So we have x all over x minus 3. So clearly you can see that we can cancel the x if you really want to make sure that we can. So if you want, let me you multiply numerator to numerator, denominator to denominator. So let's make a different color. Again, multiply numerator to numerator, denominator to denominator. What we have is um, x squared plus 2 times x all over x times x minus 3. So clearly we can divide x over x, which is going to give us 1. Okay, and what is left from here? So what is left is clearly our final answer, which is which is equal to um, x squared plus 2 all over x minus 3. Yeah, so pretty much this is our answer for number 1. This is our answer for our first video in complex fractions. So we have x plus 2 all over x minus 3. Okay, so that's how we solve complex fractions. Again, we started off with this example. More scroll. We started off with this example, pretty much complex. Okay, here, let me fix that. Okay, we started here. So we have x plus 2 over x all over 1 minus 3 over x, and then we ended up with our final answer, which is this. Okay, which is this. Okay, so yeah, that's it for this video, for for the first video in complex fractions. I'm going to proceed. We're going to proceed to one more example, and yeah, we're going to talk about this in the next video. So thank you very much. Don't forget to like and subscribe. Okay, see ya.